Good morning. In the previous session, we discussed about bitwise operators. Today, we are going to practice bitwise operators, programs on bitwise operators. In the last class, we discussed bitwise operators and their hierarchy and operations on bitwise operators. Just we recall the last session. Bitwise operators are used to manipulate data at bit level. Bitwise data manipulations are mission dependent, storing booleans efficiently, communicating directly with the hardware. Work on integer operands only. This is the important point. Bitwise operators works on integer operands only. The bitwise operators are right shift, left shift operator, exclusive OR operator, ones complement operator, bitwise AND operator, and OR operator. We'll see the hierarchy of these operators. Once complement operator has the highest priority, the associativity is right to left. Left shift and right shift operators has the second priority. It has the left to right associativity. Bitwise AND operator has third priority. It has left to right associativity. Exclusive OR operator, fourth priority. It has left to right associativity. OR operator has the fifth priority, left to right associativity. This is the hierarchy of the bitwise operator. First priority, ones complement. Second priority, left shift or right shift. Third priority, bitwise AND operator. Fourth priority, exclusive OR operator. Fifth priority, bitwise OR operator. Now we will practice the programs using the bitwise operators. Here is a one program. Swap two numbers without using a temporary variable. All you know how to swap a two numbers using a temporary variable. We will take one temporary variable and we will first swap the number 1 to temporary variable and we'll swap the second number into the first number, then we'll swap the temporary variable value to second variable. This is the swapping of two numbers using the temporary variable. Now we are going to practice execute the program swapping of two numbers without using a temporary variable, and at the same time using the bitwise operators. To achieve this program, we are using the bitwise operator exclusive OR operator. It is a 10 lines of code. The program length is only 10 lines. Observe the program. Hash include stdio.h main function int x is equal to 10, y equals to 5, x is equal to x or y. X now becomes 15, y is equal to x xor y, y becomes 10, x is equal to x xor y, x becomes 5. This is the simple logic. We are performing the XOR operations 3 times. First time x XOR y, x XOR y, x XOR y. But remember, the sequence of assigning the value is important. First operation is assigned to the x, second operation is assigned to the y, third operation again assigned to the x only. After performing this XOR operation, we are printing the resultant value. Now we'll execute the same program in compiler. Open the Turbo C++, click on the new option. Type the program hash include stdio.h main int x is equal 10, comma y is equal 5. X is equal to x XOR y, y is equal to x XOR y, x is equal to x XOR y only. Printf. After swapping x is equal to %d, comma y is equal to %d, comma x, comma y. This is the program. end of this program. uh, we are printing the resultant value, but we can also print before swapping. The same code will be control C, copy, paste. Instead of before swapping. Now save the program. Alt F, swap.c, compile the program. Compilation is successful with 2 errors. Now run the program. Alt R, see the output. We will see the output on user screen. Alt F5. Before swapping, x is equal to 10, y equal to 5. After swapping, x is equal to 5, y is equal to 10. Now we will change the variable values in the program and we will check program is working or not. Now we will change the x value as 29, y value as 72. Save the program. We'll see the output. Before swapping, x is equal to 29, y is equal to 72. After swapping, x is equal to 72 and y equals to 29. This is the simple program. By using the XOR operator, we are performing the swapping without using temporary variable. Now we will see one more program. Program to check even or odd using bitwise operator. We practice the program check a given number is even or odd using bitwise operator. In previous sessions, we practiced the same program but using the arithmetic operators, that is using the modulo operator. If a number is divisible with 2, we will say it is a even number, otherwise we will call it as a odd number. Now we are going to practice, we are going to check the given number is even or odd using bitwise operator. We use bitwise operator and operator to check whether a bit is set or not. Similarly, On performing num and 1, it returns ls of num if lsb least significant bit is 1, then the given number is odd, otherwise even. Now we will see the example. Here left side 12. It is a decimal number. The binary format of 12 is 00001100. If you perform AND operation with 1, the binary of 1 is 00000001. Then the if you perform bitwise AND operation, the resultant value it returns 0. Because in the least significant bit, every even number consists 0 only. The binary number system in the format of zeros and ones, the least significant bit of any number either 0 or 1 only. If it is 0, it is even number. If it is 1, it is a odd number. For confirmation purpose, we are performing the bitwise AND operation with 1. If the LSB least significant bit is 1, then it returns the result 1. If the LSB is 0, it returns 0. Now we will see the one more example. In the right side, the number is 15. The decimal number is 15. The equivalent of binary format is 00001111. This number is AND with bitwise operator with 1. The one binary form is 00000001. If you ANDed with these two numbers 15 and 1, then it returns the 1 because the least significant bit is 1 in the number. Then the resultant value is also 1. We will conclude it is a odd number. This is the logic behind this program. Now we will see the program. Observe this program. This is the program to find even number or odd number using bitwise OR operator. This is the expected output. Enter a number. If it is a even number, it prints it is even. If it is a odd number, it prints odd. Here we entered 15. 15 is a odd number. Now we will execute this program. In C compiler, open the C compiler. Click on File menu, select New option. You will get the new file. Now type the program #include stdio.h int main function int num printf enter any number. Scanf %d ampersand num. If num bitwise and with 1, if it is a even number, it returns 0. If it is a odd number, it returns 1. Enter \n %d is odd. Enter %d is even. This is the simple program. Now save the program. Alt F, save. Even.c, compile the program. Compilation is successful without errors. Run the program. Enter any number. 99. See the output. Alt F5. 99 is odd number. Again, we will run the program, enter a number 112. We will see the output 112 is even number. Here, if you observe the if condition, if num and 1, whenever the condition is true, it returns 1. If it is true, it is treated as 1. Num and 1 returns 1 when it is a odd number. That's why in the if block, we are writing the entered number is odd number. If it returns 0, the if statement treated as a false. Then it executes the else block instructions. This is the logic behind this if else statement. Now we will see one more program on using bitwise operator, alt X. This program to convert decimal to binary using bitwise operator. Here hash include stdio.h, hash define int underscore size is defined as size of int multiplied with 8. Size of int, it returns the integer size 2 bytes is multiplied with 8, that is assigned to the int underscore size constant. Int main function, int num and index I, 3 integer variables are declared. Int bin of int underscore size. Here one binary array, bin means binary array, is declared. Array is used to store similar type of elements with a common name. In the next session, we will discuss the arrays. You remember this point. Array is a similar type of elements stored under a common name. The array index starts from 0. Here, bin of int underscore size. Bin is the array name. Within the square brackets, we wrote the size of the array. Printf, enter any number. Scanf function is used to read the data from the keyboard. Index is equal to int underscore size minus 1. The index value is assigned here of array size minus 1. While index greater than or equal to 0, the while loop is executed Within the while loop, bin of index is equal to num and 1. Then decrementing the index value and right shift the num. This process is repeated until the condition is becomes false. After executing this loop, we will get the entered number binary format. To print the binary number, we are using the for loop for I equal to 0, I less than int underscore size semicolon I plus plus printf percentage d comma bin of I. Now we will see the expected output of this program. We will enter any number. We entered 22. The converted binary number is zeros left side almost and 10110. The word length is depends upon the machine. Now we will execute the same program in compiler. Open the Turbo C++ compiler. Click on the file menu, new option, type the program include stdio.h. By using the define macro, we are declaring one constant variable int size underscore size of int multiplied with 8 semicolon int main function int num comma index comma I. Three integer variables are declared. Int by bin array. One integer array is declared of size int underscore size. It is depends upon the mission. Printf backslash and forgetting the new line, enter any number. We are communicating by using this printf to the user, enter any number. Semicolon. The scanf function is used to read the numbers from the keyboard. Percentage d comma address of. Here in the scanf function we are using ampersand symbol and symbol. It is called as address of. If you use it in the if or expression, it is called as a bitwise and operator. Be careful while you are using these operators. The situations make the operator change. In scanf function, it is called as a address of. In a expression, it is called as a bitwise and operator. Semicolon. Index is equal to int underscore size minus 1. Here, index value is assigned to the size of the array minus 1. Then while loop, while the condition is index greater than or equals to 0. If it is true, it enter into the loop and it checks in the bin array of index is equal to num, and what I told, if the and symbol wrote in scanf function, it is called as address. Whenever it is wrote in a expression, it is called as a bitwise and operator. The same, the occurrence of the AND operator is here. In the scanf, it is called as a address of operator. In expression, we are calling as a bitwise and operator. It in the scanf function, it used to read and store the numbers in that address specified. In an expression, it is act as a bitwise operator. It performs bitwise AND operation. It performs bitwise AND operation. That value is assigned to bin of index. Now num is equal to, this num is shifted one time. This is the compound assignment or shortened assignment operator. We can write it as a num is equal to num of 1. One time it is right shifted the numbers. Semicolon. The loop is repeated until the condition becomes false. After performing here, what it is, the operation sorry in the while loop, we are checking the each and every bit of the entered number. We are performing bitwise AND operation for every bit, and that is storing. After performing the AND operation, bitwise AND operation, the resultant value is storing in bin array for printing the resultant value. Next, we are using the printf statement. converted binary number. Double quotes, semicolon. Now we use the for loop to print each and every bit that is stored in the bin array. Now we will use I is equals 0, semicolon, I less than int underscore size of the array. This is the size of the array. I plus plus. The loop is repeated until the end of the array size. It is begins from 0. The array size is int underscore size, that is declared in the beginning of the program. Printf double quotes backslash n. No, don't use this backslash n. No need to. Percentage d comma bin of I, semicolon. This is the end of the for loop. It prints the binary digits that are stored in the bin array. The loop is repeated until the end of the array size. It begins from 0. The array size is int underscore size. This is end of the program. Now we will save the program. Bin binary dot c. Now compile the program. We got 6 errors. Oh my god. Array bounds missing. Second expression syntax code has no effect. Undefined symbol bin. Expression syntax statement missing. Where it is? Compound statement missing. We will see. We will solve this problem. Now we will change the size of int is multiplied with 8. Save the program. We will check the, even though we are getting the errors. Array bounds missing. Due to the technical problem, we are unable to get the result, but the expected output is enter any number 22. Converted binary number is this is the sum of the sample programs here. Hash include stdio.h main declaring the I value, j value, k, l variables. We use the left shift operator like this: I double less than 2, j double greater than 2. It prints. These are the observe and practice these programs. Example 2, bitwise OR and XOR simple programs. Okay, thank you.